Okay, I'm going to spend a little bit of time developing this notion. Let's just say I've got a group G, and I've got X, a member of my set G, and I've got a right coset there equal to another left coset. So what that means is that n1x equals y n2. But because it's normal, I can swap that round. That's n2y and that's n1x. And then I can multiply on the left by n2 minus 1 n1x equals y. So that tells me that n3x, because of course this is still, it's a subgroup, if n's a normal subgroup, then it's still a subgroup, equals y. And that tells me that n3 equals yx to the minus 1. So that tells me, that tells me that yx to the minus 1 is a member of n, because it's n3. And so that tells me that nx equals ny, because we proved that if this relationship holds, then the left cosets are the same. And so we know that that's the case there. So nx equals yn. If nx equals yn, that effectively says that x is in the same coset as y. So if we've got that, we may as well just say that nx equals xn, because this relationship here tells us we're in the same coset. Or I may say that x minus 1 n x equals n. And this is the way that most people think about normal subgroups. There's another way of expressing it, which is that x to the minus 1 for all x in G, for all n in G, then x minus 1 n x, you see all I'm doing is writing out this thing here, is a member of n. That's really what we're saying. This is the right way to think about it. That x to the minus 1 n x is still in n. So basically we've got a map which sends n to x to the minus 1 n x, and it doesn't make any difference in the sense that it still belongs to this n here, still belongs to this normal subgroup. And that's the right way to think about it. So I'm gonna use this as my proper definition. That's the way to think about it, and I'll try and make this definition meaningful to you. We need a little bit more theory. We need to look at the symmetric group before we can fully appreciate what's going on here. But I'll give you a whole bunch of examples that show you what I mean by this. Okay, I'm going to stop there.